Today discuss about the refraction of light, the second part of the light chapter. So what is the refraction of light? As the light travels from one transparent medium to another of different densities, light deviates or bends from its original path. Now the refraction of light through glass block, we have to see that how the glass block bends the light ray, reflect the light ray. So we have the incident ray. This is my incident ray. This is my incident ray. So it travels from denser medium, from air to glass block. Air is over less dense medium, so it bends towards the normal because speed of light decreases in glass. So bend towards the normal. And when it travels from denser to less dense medium, so what will happen, that it will becomes the speed of light increases and bends away from the normal. So here the light ray bends away from the normal, and it always parallel to the extended incident ray. Emergent ray, here we have the note. Emergent ray always parallel to the extended incident ray. So this and this always parallel to the extended incident ray. So how much it deviate if it is not a full scale diagram? So we draw the emergent rays which is parallel to the extended incident ray. So this is the imaginary extended incident ray. Imaginary extended incident ray. So here is the angle of incidence. This is the angle I, angle of incidence. This is the angle of refraction. This is my refracted ray. This is the angle of incidence. This is the angle of emergence. This is the angle of emergence. Note, we have the note. This is over incident ray. This is over normal. This angle I is called angle of incidence. Incidence in less dense medium. This is my refracted ray. This is the angle of refraction in denser medium. Then if denser to less dense medium, so this is the angle of incidence in denser medium. This is the angle of refraction in less dense medium. Angle of incidence and angle of incidence in less dense medium and angle of refraction in less dense medium greater than the angle of refraction and angle of incidence in denser medium. Now the laws of refraction. Incident ray, refracted ray, and normal. Incident ray, refracted ray, emergent ray, and normal all lie in the same plane flat surface. Ratio between sine of angle of incidence to the sine of angle of refraction is equal to refractive index refractive index. So these are the two laws of refraction: incident ray, refracted ray, emergent ray, and normal all lie in the same plane flat surface. Ratio between sine of angle of incidence to the sine of angle of refraction is equal to refractive index. Now refractive index how we define it as a ratio between sine of angle of incidence to the sine of angle of refraction is equal to refractive index. Formula: n. Refractive index is represented with the n. Refractive index is equal to sine I divided by sine R. This is the angle. No SI unit. It is just ratio of numbers. Sine I has no unit. And sine R has no unit. So here we have to about that higher the value of refractive index, more denser the transparent medium. Example, n of glass is 1.5, n of water is 1.33. So glass is more denser than water. Higher the refractive index, the refractive index of transparent medium more light bends in that medium, more refraction. Sine of angle of incidence is directly proportional to sine r. Sine I is directly proportional to sine r. So directly proportional, if we plot the graph between sine I and sine r, sine I, sine r. So graph is a straight line passing through the origin. Gradient of this graph equal to refractive index. This graph is equal to refractive index. Now, whenever you calculate the refractive index of the medium, in order to calculate refractive index of medium, be careful about that sine x divided by sine y. So this angle is always less dense medium, and whose refractive index is need to be found. This one is the denser medium. So the medium of which refractive index need to be found, the angle, denser medium angle must be here. So denser medium angle, less dense medium angle. So refractive index, the material medium of which refractive index need to be found. So we have to use the denser angle at the bottom. So this is the refractive index. So it gives the ratio about that how much over denser medium, how many times my denser medium is denser than the less dense medium. Next we have refraction through glass prism. Now we have a glass prism angle, all angles are equal, all angles are equal. So we have this glass prism. So this is my incident ray, this is my emergent ray. Incident ray, emergent ray. This is the normal. And this is my refracted ray, inside the glass box refracted ray. This is the angle I, angle R, and this is the angle E. Another diagram that we have to find the mark the angle of deviation in glass prism. So angle of deviation in glass prism. So this is my incident ray, this is my emergent ray. Incident, emergent, refracted ray. So our angle of deviation is, if I extend this line, so this is my angle of deviation, this is the angle of deviation, angle of deviation. So this is the angle of deviation. Now the next topic is that refraction through semicircular glass block. Refraction through semicircular glass block. So we have a glass block, semicircular glass block. So this is my incident ray, it go through perpendicularly, so that is why there is no bending. Here we have, I bend the light rays. So as the light travel from denser to less dense medium, so light ray, denser to less dense medium, light ray bend. This is the angle of incidence, denser medium. This is the angle of refraction in less dense medium. If I increase the angle of incidence, so what will happen? Angle of refraction is also increases. If I increase the angle of incidence, So angle of refraction is also increases. So this one is increasing, more increasing. This is the angle I, more increasing. Angle R. More increasing, angle I. So angle R is also increasing. So this is the angle of refraction in less dense medium. This is the angle of incidence in denser medium. Now there is a stage come as I continuously increasing the angle of incidence. So what will happen? So at certain point angle of incidence, the angle of refraction becomes 90 degree. Angle of refraction becomes 90 degree and light ray travel along the surface. This is the angle of refraction in less dense medium. And this is the angle of incidence, in denser medium. So angle of refraction becomes 90 degree. Angle of refraction in less dense medium. We have another ray. What we call this ray? This ray is weak reflected ray. Weak reflected ray. This is a weak reflected ray. So what is meant by critical angle? Critical angle. What is meant by critical angle? So how we define? It is the angle of incidence in denser medium for which angle of refraction in less dense medium is 90 degree. Remember that this critical angle is always formed in denser medium. This is my angle of incidence. We name it the critical angle. It is always formed in the denser medium. Now the next is total internal reflection. Total internal reflection. Now total internal reflection occurs when we further increase the angle of incidence in denser medium greater than critical angle. So here we have the diagram in which we draw the diagram. This is my incident ray. This is the normal This is the weak reflected ray, and this is the emergent ray. We have the emergent ray. So this is our critical angle C. This is our critical angle. Now if we further increase the critical angle, so what will happen? If we further increase the critical angle, that our angle of incidence is greater than the critical angle, so what will happen? Now total internal reflection occurs. This is the 90, this is the 90. So all the light ray is reflected back into the same denser medium. So how we define the total internal reflection? Definition: total internal reflection. If angle of incidence in denser medium greater than critical angle, all light is reflected back into the same denser medium. So two conditions are required. Conditions for total internal reflection. Reflection word we use, reflection. So total internal reflection, angle of incidence in denser medium. First of all, light must travel from denser to less dense medium. Number 2, angle of incidence in denser medium greater than critical angle. So these are the two conditions. Condition for refraction, refraction. So condition for refraction is that light must travel from one transparent medium to another of different densities. Angle of incidence is not equal to 0. Means light ray not fall perpendicularly on the surface of transparent medium. So if the light ray falls perpendicularly, it goes straight. So it goes straight, 90-degree angle. So there is no refraction, there is no bending. Glass block. Now the next is the application of total internal reflection. Application of total internal reflection. The one is optical fiber cable and optical fiber cable. Now in optical fiber cable we have, these are glass or plastic rods used to transmit light or infrared signal. So glass passive used to transmit signal in the form of light or infrared signals in the form of infrared signals. So optical fiber cable, we have these glass rod so these are the two layers of glass. One is high refractive index and one is low refractive index. So one we have the layer of high refractive index and one we have the layer of low refractive index. This one is the glass with low refractive index and this one is the glass of high refractive index. Why we have to use two layers? Because we have to satisfy the condition for the light must travel from denser to less dense medium. So that high refractive index, glass of high refractive index denser medium and glass of low refractive index is less dense medium. So we send the infrared pulses, so it will travel along the optical fiber cable through total internal reflection. Advantages of sending telecommunication, signals. Now what are the advantages? Data infrared pulses data sent at very high rate, more immune to electrical interference. harder to tap. Light weight and cheaper than copper cable. Less boosters and repeaters are required. So data send at greater bandwidth greater bandwidth carries more number of signals. So this is the advantage of telecommunication signal as compared to the copper cable. Now we have medical usage of optical fiber cable. So medical use of optical fiber cable, we have endoscopy. So in endoscopy, what is endoscope? It is the optical fiber cable with one end connected with computer and other end have LED light and camera. So endoscopy is used to see the internal walls of stomach and intestine. So the walls of stomach and intestine can be seen with the help of this endoscopy. So what we have in endoscope, we have this computer, we have the endoscope, computer screen, endoscope, so this is the LED camera, LED light, and we have the camera. So through mouth we insert into the body and see the walls. So the light will be reflected light ray through camera travel along the optical fiber cable, and we are able to see the internal walls of intestine and stomach. So these are the light signal traveling through computer, and this we have the image of stomach image. So with the help of this endoscope we are able to see that the location of the fungus and the condition of the food canal. Now the next is right angle, triangle, prism. So in the right angle triangle prism we have right angle glass prism, glass prism. So this is the 90-degree angle, this is the 45. So we have to be this is the 45, mostly the critical angle of the glass is 42 and this is the 45 angle of incidence. So what will happen? So total internal reflection happens. So what we done, this is a 90-degree inversion of the image. So 90-degree inversion of image. So the image form horizontally. Another diagram we have, again we have right angle triangle prism. One is 90-degree angle I, 45 degree. This one is also 45 degree. So if we have the object AB, so light ray travel, so again total internal reflection occurs. So what will happen? So this one is the image. So 180-degree inversion. So the image is inverted. Another example of the path ray. So this one the 90-degree. So if we have A, so what will happen? This will be 180-degree inverted. So in this way, 180-degree inverted image. So totally inverted image of this. This is the right angle triangle prism, and now we have the prism periscope. So now we have the prism periscope. So in prism periscope we have the periscope Z-shaped tube. So in the Z-shaped tube we have two prism, right angle triangle prism. So the light ray travel and totally internal reflection occurs. And the same image properties which is formed by mirror periscope. So this is the image. This is the right angle triangle prism. So ATP part verify laws of refraction by ray or pen method. Find a refractive index of glass block by ray or pen method. Find critical angle of glass block by ray or pen method. So these are the experiment used to coming in the ATP past paper. Thank you.